Okay, I have to record this lesson. Now we are discussing transformers. How do transformers work? To know how transformers work, we need to know that transformers actually consist of three physical parts. One is a primary coil. Other is a secondary coil. And the third one is the iron core. The central rectangular part is iron core. This is primary coil. And you can also call it input coil, or you can call it first coil. This one, on the other hand, is secondary coil, or output coil. Now, what are the roles of these three parts? Now, when an alternating current passes through primary coil, it produces an alternating magnetic field. What is meant by term alternating magnetic field? Alternating current is continuously changing direction and it is continuously changing its magnitude. That is what alternating means. When current will be alternating, its magnetic field will also be alternating. In the primary coil, this coil, when an alternating current passes through, it produces a magnetic field which is also alternating. Iron core's job is to transfer that magnetic field and its variation to the secondary coil efficiently. So now iron core transfers magnetic field and its variation to secondary coil efficiently. Technically, for the system of transformer to work, iron core is not needed. Iron core just increases the efficiency. It is not doing the transformation thing. That is only done with the coil 1 and coil 2. Iron core is just increasing the efficiency. Its job is to efficiently transfer the magnetic field and its variation from primary coil to secondary coil. Now, what happens because in the secondary coil? In secondary coil, magnetic flux changes for secondary coil. This change produces an alternating EMF in secondary coil. So when there is an alternating current in the primary coil, there is an alternating current in the secondary coil. Now there is a question. If input is a alternating current and output is also an alternating current, then why do we use this thing? What does it do? The answer is transformer is used to increase or decrease the voltage of alternating current. If we want to increase the voltage of alternating current, we put less coil or less turns of coil in the primary coil and more turns in the secondary coil. That will make this transformer a step up transformer. Okay. Let me write that down because that is important. As we discussed in the previous lesson as well, you can see over here, number of turns and voltage are directly proportional. Wherever there will be more turns, if there are more turns in the primary coil than the secondary coil, then there will be more voltage in the primary coil than the secondary coil. And if there are less turns in the primary coil than the secondary coil, there will be less voltage in the primary coil than the secondary coil. Step up transformer. Number one, voltage in the primary will be less than voltage in the secondary. It means input voltage will be less and output voltage will be more. Secondly, number of turns in the primary will be less than number of turns in the secondary. And this type of transformers are used to increase the voltage of alternating current. At this point, you might be thinking that why transformers only work with alternating current. Answer is because alternating current have a variable magnetic field. So when magnetic field changes, it automatically produces a continuous EMF in the secondary coil. Step down transformer. Voltage in primary is more than voltage in secondary. It means input voltage is more and output voltage is less. And for this kind of transformer, number of primary turns are more than number of secondary turns. Okay. Any confusion till this point? Because a step-up transformer is used to increase the voltage and step-down transformer is used to decrease the voltage. So now, moving on, we will be discussing hello, can you people hear me? Can
Yes, sir.
anyone
Yes.
confirm that you can hear me? Okay. I think I lost the connection for some time. Now, listen, step-up transformer is to increase the voltage and step-down transformer is to decrease the voltage, number of turns and voltage. I have explained that. Now, I will be telling you some very important formulas that will help you to solve the questions. Number one, number of turns in the primary coil divided by number of turns in the secondary coil equals to voltage in the primary coil divided by voltage in the secondary coil. Because you can see there is NP at the top over here, number of turns in the primary, and you see voltage in primary, and they are directly proportional. That's why they are in the same line on the either side of the equal sign. But transformers are not the source of power. That means power input or power at the primary should be equal to power at the secondary. What is the formula for power? Power is voltage multiplied by current. So VPIP equals to VSIS. And that is also a very important formula for you to solve problems of finding current or missing voltage or something. But if I make voltage or gather voltage on one side and current on the other side, you see a very strange thing. VP over VS equals to IS over IP. So apparently power and voltage are inversely proportional to one another. I'm about to ask a very weird, a very tricky question. And when you will be like learn more of physics, you will understand that the question is incorrect. Question is that whether voltage and current are directly proportional to one another or inversely proportional to one another. And before you answer the question, think twice. Voltage and current, are they directly proportional to one another or they are inversely proportional to one another? What is the formula to see or connect voltage and current?
V equals to IR.
V equals to IR. So if I go for V equals to IR, I see that V and I are directly proportional to one another because V and I are in the same line on either side of the equal sign. Now, power equals to VI. If I make V subject of formula over here, it becomes power divided by current. So what do you see now? Voltage equals to current into resistance, power equals to voltage into current, and voltage equals to power divided by current. When I see this formula, I find voltage and current to be directly proportional. And when I see the last formula, I find voltage and current to be inversely proportional. Which one is correct? Oops, they both are correct. So, what is happening? Can anybody explain?
Inversely.
If we are using power, then we will use the last equation, inverse one.
I think you are somewhere very close to the correct answer, but can you use proper wording? Your wording is a bit sloppy over here. Can anybody else? So here, actually, answer is hidden in the one that you don't see. Voltage is directly proportional to current. What R is doing over here, and voltage is inversely proportional to current. What P is doing over here. These are the things that will explain you what is happening. Listen. If there is a situation that voltage and current are changing, but the resistance is staying constant, then voltage and current will be directly proportional. And if there is a situation where voltage and current are changing, but the power is staying constant, voltage and current will become inversely proportional. And that is what is happening over here. In this case, we see that the power in the primary is equal to power in the secondary. So when power in primary is equal to power in secondary, then voltage and current are inversely proportional, because in this case, the power is staying the same. Now, because transformers only work with alternating current, and that's why alternating current has some features over here that we have discussed in the previous classes, that the peak voltage is known as V naught, peak power is P naught, P current is I naught, then there are RMS values as well. So question is that for what values we can use these equations? Is there any rule that should we use root mean square value all the time, or should we use the maximum value or the minimum value? Answer is that if you put the maximum value of voltage, you'll get maximum value of voltage in the secondary. If you put RMS voltage, then you will get RMS voltage. So it doesn't matter. The formula works for both, but you have to be careful. You cannot put one voltage in RMS and one voltage in peak value. And you first have to convert the peak value to the RMS value or RMS value to peak value. But remember, the both values should be same. No. Voltage and power. Good. Now, one thing, efficiency of transformers. If transformers are K% efficient, then remember K% of power in primary equals to power in secondary. So K over 100 into voltage in primary into current in primary equals to voltage in secondary and current in secondary. Anyone has any question till now? Nope.
No, sir.
Good. Then I have questions for you. Why transformers only work with alternating current?